Welcome to the Lazy Scientist, a place where the noise of the day begins to fade and the quiet of the night takes hold. This evening, we're setting out on a journey far beyond the familiar skies above your head, to regions of the cosmos where entire galaxies roam and, from time to time, drift into each other's paths. It doesn't happen in a rush, not like the sudden collision of cars or the crash of waves on a shore, but more like a slow dance, movements measured not in minutes, but in spans of billions of years. Before we begin, I'd like to pause and ask, where are you listening from tonight? Perhaps you're curled beneath the covers, perhaps on a sofa as the lights dim, or maybe by a window, eyes catching a glimpse of the night sky. Wherever you are, I'm glad you've joined. If these explorations bring you peace, leaving a like or subscribing helps this small corner of the universe reach others who may also need quiet stories. And for those already on this journey with me, thank you for being part of this calm voyage. I'll try not to keep you awake too long, but if you linger a little, you'll leave with new wonders to carry into your dreams. So as your eyes soften with sleep, let's begin. After all, what really happens when galaxies collide? On first thought, the idea of two galaxies meeting seems catastrophic. A word like collision conjures images of violence, stars smashing, worlds destroyed in flashes of fire. Yet the reality is far gentler. These encounters unfold with a patience so vast that the very concept of time begins to feel different. Galaxies, enormous collections of stars, gas, and invisible matter, do not sit still. They wander, tugged along by the invisible pull of gravity, and when their paths cross, they reshape each other in a slow, almost tender embrace. Their fates are drawn out over such immense spans that even the rise and fall of entire civilizations on Earth are but single heartbeats in the timeline of their union. In our exploration tonight, we'll move slowly, step by step, through this grand choreography. We'll uncover how these immense gatherings take shape, what happens to the stars, planets, and clouds of gas swept into their gravity, and how dark matter and hidden black holes play their part in the drama. We'll also gaze ahead into the far future, when our own Milky Way is destined to meet its neighbor Andromeda in a celestial merging scripted billions of years before humanity even took its first breath. Nothing here will be hurried. Like the galaxies themselves, we will drift at an unhurried pace, noticing the quiet beauty of each moment. Because within the story of galactic collisions lies a reminder, even the most immense changes can unfold gently, transforming chaos into creativity. Step back in your imagination, far enough to leave behind our solar system, far enough to move past the faint glimmer of nearby stars. What you would see is not an empty void, but a pattern, an arrangement of light, so vast it strains the mind. The universe is not random. It is composed of immense, shining cities of stars. These are galaxies. Each is an island of brilliance floating in the dark sea of space. Each contains hundreds of billions of suns, vast oceans of gas, drifting dust, and an invisible substance we call dark matter, something that outweighs everything we can see. Galaxies are not ornaments sprinkled across the cosmos. They are its foundation stones, the great archipelagos of an endless ocean. Think of a city at night seen from far above, lights spread out like threads of gold, forming patterns that trace roads and neighborhoods. Each light represents countless lives. In a similar way, Each point of light in a galaxy is a star, and each star may host worlds of its own. Galaxies are communities on an unimaginable scale. Take the Milky Way, our home. It is a barred spiral galaxy, a pinwheel of light with a shining bar of stars crossing its center. Somewhere between 200 and 400 billion stars call it home. Around many of those stars orbit planets, and on at least one, life arose and now wonders at the whole. Despite this unthinkable complexity, the Milky Way turns as a single unit, a wheel spinning silently in the dark. What keeps it together? Gravity, the quiet architect of the cosmos. This invisible sculptor bends space itself, pulling stars, gas, and dust into coherent patterns so they do not drift apart into nothingness. But gravity's story doesn't end there. The light we see from stars and nebulae is only a fraction of what holds galaxies together. Surrounding them is something unseen, something heavier than all the stars combined. Dark matter. We cannot detect it directly, but without it, galaxies would not remain bound. They would spin apart like sparks from a firework. Dark matter is the hidden framework that ensures galaxies endure. Galaxies come in many forms, each shaped by history and circumstance. Spirals are perhaps the most famous, gracy disks with arms curling outward like vast cosmic whirlpools. Their arms shimmer with clusters of young, blue stars, born in waves of density that move through the disk. Our Milky Way is one such spiral, its arms wrapping around a central bar of older stars. From a distance, spirals are breathtaking, as though the universe itself has sketched designs across the sky with light. Then there are ellipticals, more understated, shaped like glowing orbs. They lack the dramatic arms of spirals, containing mostly older stars glowing golden with age. The largest galaxies we know are ellipticals, massive giants thought to be the results of countless mergers. They are dignified, carrying the quiet weight of long histories. And then there are irregular galaxies, the rebels. They defy neat classification, appearing chaotic and asymmetrical, often the result of turbulent pasts or disruptive encounters with neighbors. Some are small, some unexpectedly vast, but all remind us that not everything in nature fits into tidy categories. Astronomers also speak of size. Some galaxies are immense giants with trillions of stars, while others are dwarfs with just a few billion. Dwarf galaxies, though small, are the most common, scattered cottages compared to the skyscrapers of spirals and ellipticals. Our Milky Way itself has several dwarf companions, the large and small Magellanic Clouds, faintly visible from the southern hemisphere as ghostly smudges. Over time, these smaller galaxies will likely be drawn into and absorbed by the Milky Way. Nothing in the universe is truly still. Galaxies are not frozen paintings. They are living systems. Stars orbit within them. Gas clouds drift, collapse, and ignite new suns. Spiral arms ripple like waves across a pond. Every galaxy is a story in motion, spanning billions of years. From the birth of fiery young stars to the fading of the ancient, they hold within them the entire cycle of stellar life. Despite their grandeur, galaxies are also fragile. Their elegant arms and bars exist only because of a delicate balance between mass, gravity, and motion. Disturb that balance, and the shapes can twist, warp, or even dissolve into new forms. Neighboring galaxies can pull on one another, creating long, luminous bridges of stars, or stretching them into elongated tails. In this way, galaxies reveal both resilience and vulnerability. Surviving for billions of years, yet always open to transformation. When astronomers first turned their telescopes to the sky, they noticed faint smudges and debated their nature. Were these misty clouds inside the Milky Way, or entire island universes beyond? The mystery lasted until the early 20th century, when Edwin Hubble provided the answer. Those smudges were galaxies in their own right, each a universe of stars far outside our own. That discovery expanded our view immeasurably. Today, with modern telescopes, we know that the observable universe holds more galaxies than there are grains of sand on Earth's beaches, trillions upon trillions of star cities, each carrying its own unique history. And in this sea of light, our Milky Way, vast as it is, might seem ordinary. Yet it is anything but. It spans roughly 100,000 light-years. At its core lies a supermassive black hole, an invisible giant around which everything turns. From Earth, we see our galaxy as a soft band of light arcing across the night sky. It is a reminder that we are not simply inhabitants of a planet or even a solar system, but citizens of an immense galactic community. Galaxies are the universe's neighborhoods, but with fewer disputes and more slow-motion embraces. Rarely isolated, they interact constantly, sometimes brushing past each other, sometimes merging into something altogether new. Each one has its own identity, its own rhythm, and its own place in the vastness of existence. To understand galaxies is to understand the stage on which the universe plays its drama. They are the backdrop and the actors, silent yet majestic, always in motion. Though the naked eye sees only a handful, telescopes reveal the truth. Galaxies stretch across the horizon of the universe. Each turns slowly in the dark. Each shines as a beacon of light against infinity. At first glance, the universe seems still. Stars appear locked in constellations. The Milky Way arches steadily overhead. Galaxies hang like faint smudges. But behind this calm lies constant motion. Galaxies drift, swirl, and collide, moved by forces both familiar and mysterious. To understand their behavior, we must meet the great sculptors of the cosmos, gravity and dark matter. Gravity, though easy to overlook, shapes everything. It keeps your feet on the ground, pulls an apple from a tree, and guides the moon around Earth. Isaac Newton described it in precise terms, and Albert Einstein later expanded the picture, revealing gravity as the warping of space and time itself. Galaxies bend reality with their mass, and stars follow those curves. Gravity is the artist that gathers gas into stars and stars into galaxies. Without it, nothing would exist. No suns, no planets, no life. Yet gravity alone does not tell the full story. When astronomers measured galaxies, they found something puzzling. The visible matter was not enough to hold them together. Galaxies spun too quickly. By the math, they should have flown apart long ago. Something unseen was missing. That missing presence is dark matter. Despite the mysterious name, it isn't sinister. It simply means matter that does not emit or reflect light. It's invisible, detectable only through gravity's pull. Current estimates suggest dark matter accounts for about 85% of the matter in the universe. Imagine a glowing lantern surrounded by a vast invisible balloon. The lantern is the stars, but the balloon, the framework holding everything together, is dark matter. Without it, galaxies would collapse into chaos. Dark matter is the unseen scaffolding of the cosmos. Although its true nature remains elusive, we know what dark matter is not. It isn't the same kind of matter that makes up our bodies, the air we breathe, or the ground beneath our feet. It isn't hidden clouds or faint stars. Decades of research have ruled out those options. It seems to be some new form of particle, one that interacts little with light, but whose influence is everywhere. Around the world, scientists have built detectors buried deep underground, hoping to glimpse even the faintest trace. So far, it remains hidden, but its fingerprints are everywhere. Without it, galaxies could not exist in the shapes we see. It is the quiet partner to gravity, together weaving the grand structure of the universe. Gravity and dark matter work hand in hand to sculpt the universe. They do not act alone, but together weave the filaments of the cosmic web. Galaxies gather where invisible threads of dark matter intersect, forming clusters, superclusters, and beyond them, vast voids nearly empty of stars. If you could somehow step outside the universe and look back, you would see an immense three-dimensional lattice, like a spider's web stretching across billions of light years. Galaxies sparkle along those threads, drawn together by the gentle tug of gravity, held in place by the unseen weight of dark matter. It is an architecture both fragile and immense, a pattern too vast for human imagination, yet one that underlies everything we know. But why do galaxies move at all? If gravity binds them so carefully, shouldn't they remain like beads strung neatly on a cosmic necklace? The answer lies in their beginnings. In the infant universe, there were slight irregularities, tiny ripples in density that made some regions just a little denser than others. Gravity, always eager to amplify imbalance, drew matter into those regions. As matter fell inward, it did not travel in straight lines, but along curved paths. That imparted motion, spin, drift, rotation that persists to this day. Galaxies were born with movement. Even now, they continue to feel the tug of their neighbors, shifting under the influence of distant masses. The Milky Way, for example, is not floating quietly. It is racing toward the Andromeda galaxy at hundreds of thousands of miles per hour. The vastness of space ensures that this meeting will not occur for billions of years, but in cosmic terms, it is already set in motion. Galaxies are not isolated marbles. They are partners in a vast gravitational dance, each step shaped by every other. When galaxies approach one another, something extraordinary happens. Their outskirts feel each other's pull long before their centers meet. Stars shift into elongated tails. Clouds of gas compress, igniting bursts of star formation. Sometimes, the galaxies simply brush past, distorted but still separate. Other times, they entwine fully, merging into new shapes. What looks like chaos is in fact the patient unfolding of physical law across inconceivable distances. Gravity is a patient choreographer. It works not in seconds, but in eons. Human beings think of collisions as sudden, violent events, but on galactic scales, a collision is a drift lasting hundreds of millions of years. Two galaxies move toward each other like vast clouds merging. Stars live entire lives during the encounter, burning brightly and fading, while the galaxies themselves continue their slow embrace. Dark matter plays an equally vital role in these meetings. While visible stars and gas may be tugged into strange arcs, the enormous halos of dark matter surrounding galaxies pass through one another like ghostly balloons. These halos are far larger than the luminous parts of galaxies and help determine the outcome of mergers. By watching such events unfold, Astronomers can map dark matter's otherwise invisible distribution. In this way, galaxy collisions are not just spectacles of beauty, they are laboratories for understanding the unseen. From these truths emerges a profound realization. The universe is not static. It is not a gallery of frozen ornaments, but a living web in constant motion. Gravity bends paths, dark matter steadies frames, and together they shape beauty on the grandest scales. To gaze upon a galaxy is to see the balance between what we understand and what remains mysterious. It is to witness the patient artistry of the cosmos. Understanding these forces does not merely explain shapes in the night sky. It reveals why the universe is structured at all. Without gravity, matter would never have gathered into stars. Without dark matter, galaxies would never have held together long enough for stars to forge elements, planets, and eventually life. Every breath, every thought, every dream is linked to these silent shapers. The universe is vast, but its story is written by surprisingly few characters, each with a role as old as time itself. Galaxies may appear still, but they are anything but static. They are travelers, reshaping themselves across spans so long that even the life cycles of stars seem fleeting by comparison. To truly grasp galaxies is to step outside human time and into a narrative told in billions of years. Every galaxy begins as a gathering of matter after the Big Bang, nearly 14 billion years ago. Back then, the cosmos was filled mostly with hydrogen and helium, spread almost evenly. Yet, within that near-uniform sea were ripples, tiny variations in density. Over immense stretches, gravity magnified those ripples, pulling more and more matter inward. The first galaxies emerged as clumps of stars, irregular, chaotic, lacking symmetry. They were seedlings, bright with youthful stars, fueled by abundant gas. Compared to the majestic spirals and grand ellipticals we see today, these early systems were messy, but they carried the potential for growth. As ages passed, galaxies evolved through inner processes and external encounters. Inside, stars lived and died, each generation enriching the surrounding gas with heavier elements: carbon, oxygen, iron. These ingredients seeded planets, and perhaps, in at least one corner of the universe, sparked life. Each new generation shifted the galaxy's character, gradually changing its color from youthful blue to a more mature golden glow. Externally, galaxies were shaped by encounters with neighbors. The early universe was more crowded than today, so collisions were frequent. They were not brief accidents, but long events stretching across hundreds of millions of years. Stars rarely collided directly. They are too small and too far apart for that. But the structures of galaxies changed dramatically. Gas clouds collided, triggering new star formation. Spiral arms stretched into tails. Two galaxies might eventually merge into one. These events were not merely destructive. They were creative, forging giants from smaller systems. The largest ellipticals are thought to be monuments to such unions, swollen by countless mergers. Even our Milky Way carries scars, streams of stars, remnants of smaller galaxies it has consumed. Its future includes an eventual grand merger with Andromeda. Over time, galaxies transform. Spirals may exhaust their gas, slow their star formation, and fade into reddish quiescence. Repeated mergers may smooth their shapes into ellipses, erasing delicate arms. Billions of years later, they glow faintly with ancient stars, quiet after once being vibrant. On these scales, even the lifespan of dinosaurs on Earth seems like a brief spark. Galaxies do not hurry. Their stories unfold with a patience beyond human comprehension. And yet, there is comfort in this. To know that galaxies endure for billions of years is to see that the universe allows time for cycles to complete. Collisions, births, and deaths of stars are not interruptions, but natural rhythms. Galaxies are resilient collectives, capable of surviving upheavals that would be catastrophic on smaller scales. They live not in isolation, but in constant conversation with their environment. Some evolve quietly, others in crowded regions are transformed rapidly by repeated encounters. The variety we see today is a snapshot of their journeys, spirals that may one day become ellipses, irregulars that may settle into new forms. The universe is always sculpting with gravity and chance. When we reflect on these immense timescales, perspective shifts. Human concerns, measured in hours and days, are fleeting compared to the drift of galaxies. And yet, rather than making life feel small, the contrast can soothe. The universe is vast enough to hold both the brief flicker of human stories and the long arc of galaxies. Each has its place in the tapestry of existence. To look at a galaxy is to witness time stretched into almost unimaginable lengths. Its light has traveled millions of years to reach us, carrying messages from the past. And as we observe it, the galaxy continues evolving, reshaping itself slowly. Galaxies are not merely clusters of stars. They are chronicles of time itself, monuments to patience and change. Galaxies are not frozen ornaments suspended in space. They are restless beings, constantly sculpted by the company they keep. In the crowded youth of the universe, when distances between galaxies were far smaller than they are today, interactions were common. Collisions were not sudden explosions, but prolonged encounters, unfolding across spans of hundreds of millions of years. These events were slow enough that stars, despite numbering in the billions, almost never collided directly. Stars are like scattered grains of sand, placed miles apart. Even when two galaxies overlap, the chances of a direct impact are vanishingly small. Yet the overall structures of the galaxies transform. Gas clouds slam into one another, compressing and sparking bursts of star formation. Spiral arms stretch like ribbons pulled by invisible hands, tidal tails arcing into the dark. And in the grandest cases, two galaxies entwine completely, merging into something larger, reshaped but still luminous. It is easy for the human imagination to leap to images of destruction when we hear the word collision. We picture chaos, explosions, the heavens torn apart. But in truth, galactic collisions are as much about creation as they are about transformation. Without these interactions, galaxies would never have grown into the immense forms we see today. The giant ellipticals that dominate the crowded cores of clusters are monuments to these unions, bloated by countless mergers, their stars now glowing with a quiet golden age. The Milky Way, too, carries scars of its history, faint streams of stars across the halo that once belonged to smaller companions, now absorbed. Its spiral form, elegant as it is is not permanent. Its past has been shaped by collisions, and its future includes an inevitable meeting with Andromeda, already drifting toward us in a slow-motion embrace. When we pull back far enough to view the full life cycles of galaxies, we see their dynamism laid bare. A spiral galaxy with bright blue arms may one day exhaust its reserves of gas. With fewer new stars being born, its glow shifts to red, its energy quiets, and it settles into a more subdued phase. Over billions of years, repeated mergers gradually smooth away its delicate arms, leaving a rounded elliptical shape. By then, most of its stars are elderly, burning faintly as they near the ends of their lives. The galaxy itself, though still vast, takes on the air of a city at dusk, no longer bustling with youthful brilliance, but still holding the memories of its long journey. Such timescales are nearly beyond comprehension. We might say a collision takes hundreds of millions of years, but to truly grasp this is to confront the limits of human imagination. The rise and fall of civilizations on Earth span mere thousands of years. The entire reign of the dinosaurs, creatures who walked the planet for over 100 million years, was only a single act in a galaxy's story. To the galaxies, even the lifespans of stars are but chapters, while human history flickers like a candle in the wind. And yet there is something oddly comforting in this immensity. To know that galaxies live for billions of years is to realize that the universe is not in a rush. It allows cycles to unfold fully. Collisions, mergers, and bursts of star formation are not interruptions, but part of the natural rhythm. Galaxies are not fragile in the way a single world might be. They are resilient collectives, capable of enduring encounters that would annihilate smaller systems. Our own galaxy is a perfect example. Astronomers have traced streams of stars across its skies, remnants of dwarfs once torn apart and absorbed. These trails whisper of an ongoing story, reminding us that galaxies live not alone, but in constant dialogue, reshaped by neighbors, enriched by encounters, slowly writing their stories across the night. The diversity of galaxies we see today is really a gallery of past journeys. Each shape is a frozen moment in time, a snapshot of motion too slow for us to witness in full. Spirals may fade into ellipses, irregulars may be tidied into more coherent forms, giants may continue swelling through mergers, while dwarfs are steadily consumed. The universe is always at work, sculpting with gravity and chance, shaping and reshaping its luminous creations. And when we reflect on these vast timescales, perspective shifts. Our worries, measured in hours and days, feel small compared to the silent drift of galaxies. But this contrast does not diminish the human story. It places it in context. Both the brief flicker of life and the billion-year arc of galaxies belong to the same tapestry. To gaze at a galaxy is to witness time stretched beyond imagination. The light that reaches us tonight may have left its stars millions of years ago. When we look, we see not the present, but echoes of ages long past. And yet the galaxy continues on, evolving slowly, reshaping itself long after we are gone. The phrase galaxies colliding tempts the imagination toward fire and chaos. We picture stars colliding like bumper cars, planets flung into voids, cosmic catastrophes tearing space apart. It sounds like a scene from a science fiction epic, but the truth is gentler, almost serene. The science of galactic collisions reveals processes that are slow, transformative, and graceful. The first fact to understand is that stars almost never meet directly. Though a galaxy contains hundreds of billions of suns, the distance between them is so immense that even during an overlap, they glide past each other untouched. Imagine two swarms of fireflies drifting together in the night. The paths overlap, but the fireflies themselves rarely collide. What does change, however, is the gravitational field, which distorts the galaxy's structures. Their outskirts stretch into luminous arcs. Gas clouds, far larger than stars, do crash, and when they do, the results are spectacular. Compressed gas collapses into new stars, igniting bursts of light that flare across the galaxies. These starbursts, fierce and bright, are among the most stunning consequences of collisions. Massive young stars blaze briefly, then explode as supernovae, scattering heavy elements that seed future planets and life. In this way, collisions enrich the cosmos with the ingredients of existence. They are not endings, but acts of renewal. Equally remarkable is how collisions rearrange stellar orbits. While stars rarely strike each other, their paths are altered by the shifting gravity. Some are cast into elongated arcs, others drawn inward toward the galactic center. Whole systems may be displaced, carried from one neighborhood of the galaxy to another. Imagine looking up at the night sky from such a world. Over eons, the familiar constellations would dissolve, replaced by new patterns as the galaxy reweaves itself. But for those living on such a planet, the change would be invisible across a lifetime. That is the essence of galactic time. Movements so slow that entire civilizations rise and fall without seeing the stars shift. The myth of violent galactic collisions lingers, but reality is calmer. Galaxies pass through one another like ghosts, their stars largely untouched. It is the gas that collides, the dark matter halos that mingle, the shapes that transform. Even the word collision misleads. It is less a crash and more a merging, a dance guided by gravity's patient hand. When galaxies of equal size meet, they may eventually settle into a new form. Spirals unravel, arms dissolve, and an elliptical galaxy emerges from the union. Chaotic at first, the system gradually relaxes into calm. Every elliptical galaxy we see today is a monument to ancient collisions, carrying within it the memory of unions long past. Sometimes the encounter is unequal, a giant swallowing a smaller companion. Astronomers call it galactic cannibalism, though the image is harsher than the reality. The smaller galaxy is stretched apart, its stars scattered, its gas absorbed. Faint streams left behind circle the larger galaxy as ghostly trails, scars of the meal. Our own Milky Way is in the process of such feasting, steadily consuming its dwarfish neighbors, weaving their remains into its halo. Even in these asymmetrical unions, the story is one of continuity. Nothing is wasted. Every star, every cloud, every orbit finds a new place in the evolving whole. Gas, unlike stars, cannot simply glide past without interaction. Clouds of hydrogen and dust are vast enough to collide directly. And when they do, waves of shock ripple through them. These shocks bleed away energy, allowing the gas to collapse inward. As it sinks toward the heart of the galaxy, it can fuel the immense black holes that lie at the centers. Normally quiet, these black holes can suddenly awaken when fed a feast of gas, flaring to life as active galactic nuclei. For a time, the galaxy's core may outshine all its stars combined, glowing across cosmic distances. In extreme cases, the black hole's hunger transforms it into a quasar, one of the brightest objects in the universe, powered by matter spiraling inward at near light speed. In this way, collisions not only spark new stars, but can also rouse the hidden giants at galactic centers, turning quiet galaxies into beacons visible halfway across the cosmos. Yet, for all their grandeur, these transformations are glacial in pace. The first approach of two galaxies can take hundreds of millions of years. Their dance of near passes, separations, and returns may stretch over 1 billion. Only after this long courtship do they finally merge into one. To place that in human terms, 1 billion years is the span it took for life on Earth to grow from simple single-celled organisms into the rich diversity we know today. While galaxies circle and sway, entire biospheres can rise, thrive, and vanish without ever witnessing the full performance. It is humbling, but also strangely reassuring to know that the universe moves with such patience. For astronomers, these encounters are both history and prophecy. By observing galaxies caught in various stages of merging, they can reconstruct the timeline of such events, piecing together the long film reel from single frames. The antennae galaxies, for example, are two spirals currently entwined. Their luminous tails stretch outward like curved feelers, strewn with clusters of newly born stars. The Whirlpool Galaxy, meanwhile, bears the unmistakable tug of a smaller companion disturbing its arms. Each of these snapshots is a window into process, revealing not destruction, but rebirth. The patience of gravity ensures that what looks chaotic in one moment settles into elegance in the next. And from this patience comes beauty. Structures so striking, they blur the line between science and art. Long tidal tails of starlight arc outward, curling into the dark like luminous ribbons. Bridges of stars and gas stretch between galaxies, glowing handshakes across the void. Streams unravel in looping patterns, racking galaxies like necklaces of scattered diamonds. Our own Milky Way is surrounded by such traces, relics of smaller galaxies already consumed. These features are not permanent, lasting only a few 100 million years before fading back into the larger whole. But while they exist, they are spectacles of almost haunting elegance. They are the brushstrokes of gravity itself, sketching arcs and curves across a canvas measured in hundreds of thousands of light years. Astronomers capture these works of cosmic artistry with instruments tuned to every wavelength of light. Ultraviolet observations reveal clusters of newborn stars glowing blue in tidal tails. Infrared shows warm dust where stellar nurseries are hidden, glowing gently in the darkness. Radio telescopes trace hydrogen gas stretched across immense distances, the raw material of future generations of stars. Each wavelength tells part of the story, and together they reveal collisions not as messy accidents, but as composed symphonies, each layer of light adding another note. Beyond observation, modern computers allow us to simulate these dances. With millions of particles representing stars, gas, and dark matter, astronomers set galaxies on a collision course and watch the results unfold in fast forward. Spirals twist, bridges appear, and tails unfurl exactly as they do in reality. These simulations are not only tools for science, they are mesmerizing performances, compressing billions of years into moments we can watch. They show how simple laws, repeated over vast scales, create patterns of immense complexity and beauty. And what patterns they are. The galaxies sway and stretch, recoil and return, much like dancers performing a duet. Their movements follow gravity's rhythm, every step deliberate, every gesture inevitable. Over time, chaos yields to calm. Two galaxies become one, the dance ending in quiet embrace. Observers on Earth liken these forms to brushstrokes, calligraphy, sculpture, ballet. Though there is no artist behind them, the parallels are undeniable. The arcs of tidal tales mimic the sweep of a painter's hand. The luminous bridges resemble trails of silk stretched across the night. The concentric ripples of the cartwheel galaxy resemble circles on water after a stone's fall. These are the patterns of physics, but they stir us the way art does, reminding us that beauty does not require intention, only the unfolding of natural law. Consider the antennae galaxies, among the most iconic examples of a collision in progress. From our vantage point, they appear locked together, their glowing cores bright, their tails extended like long, delicate arms. Inside those tails, young clusters blaze with new life, the result of gas compressed by the galaxy's interaction. What might seem like destruction is instead a nursery for thousands of suns. Or take the Cartwheel Galaxy, whose striking ring formed when a smaller companion pierced through its larger disk. The impact sent ripples outward like waves from a pebble in a pond, igniting concentric bursts of star formation. Today, the Cartwheel glows like a cosmic jewel, its outer ring blazing, its center still glowing faintly where the first ripple began. These examples remind us that galaxies are both fragile and resilient, capable of transforming chaos into elegance. The forms are temporary, however. Tidal tales disperse, bridges collapse, streams fade. The structures that captivate us are fleeting, brief flourishes in a cosmic dance that spans eternity. And yet the fact that we exist at just the right moment to witness them is a gift. It is as though the universe occasionally pulls back the curtain, offering glimpses of its artistry before the stage resets. To witness a galactic collision is to see creation in progress, to watch the raw forces of the cosmos weave new forms. It is proof that even in upheaval, the universe produces beauty. Collisions are not wrecks, but transformations, reminders that change need not mean ruin. They are the universe's way of composing on scales beyond our comprehension. Imagine, then, the galaxies as dancers on a stage of infinite darkness. They drift toward one another, drawn by gravity's music. Their arms stretch into luminous ribbons. Their gas clouds shimmer with new stars. Slowly, deliberately, they move together, not rushing, not colliding with violence, but gliding in a patient waltz. To the human eye, bound by decades, the dance is imperceptible. To the universe, it is natural rhythm. Each step lasts millions of years. Each gesture stretches across epochs. The galaxies bend, sway, and finally merge into one, the dance ending in embrace. This is the Galactic Ballet, a performance written not in seconds, but in billions of years, illuminated not by stage lights, but by the glow of countless suns. And perhaps that is the most soothing lesson hidden within these cosmic encounters. That what seems at first like chaos is, in truth, a slow unfolding of order. That what looks like destruction is often the seed of renewal. That beauty can emerge from collision, if only we stretch our perspective wide enough. To drift with galaxies is to learn patience, to surrender to scales of time far beyond our own. It is to realize that the universe, even in its most immense transformations, moves with grace. And as you settle deeper into rest, picture these galaxies gliding across the dark, their trails of starlight curving into infinity. A lullaby written in light, a performance choreographed by gravity. A reminder that even in upheaval, the universe is serene. As we linger on the imagery of galaxies twirling and stretching, it's easy to forget that these grand shapes were not always so mature, so refined. The arcs and sweeping curves that today we find so elegant are the result of billions of years of growth, of change, of encounters that continually sculpt the universe into what we see. Just as every city carries the story of its beginnings in its oldest streets and foundations, galaxies, too, carry with them the memory of their youth. To understand their grandeur, we must follow their lives backward, to the first sparks of light after the great darkness that followed the birth of the universe itself. The early cosmos, in the wake of the Big Bang, was not yet adorned with glittering spirals or sprawling ellipses. Instead, it was filled with vast seas of hydrogen and helium, gas stretched almost uniformly across space, thin and quiet. Yet, this uniformity was not perfect. There were ripples, tiny fluctuations in density, imperfections so small that they seemed inconsequential at first. But gravity is patient, and in those slightly denser regions, matter began to gather. Over immense spans of time, those gatherings grew into the first galaxies, small and irregular, flickering into being like candles in an endless night. At this stage, galaxies were far from the majestic spirals and luminous giants we see today. They were chaotic, full of young, bright stars that had only just ignited from collapsing clouds of gas. These stars burned fiercely, their light sharp and blue, but their lives short. They exploded as supernovae, enriching the surrounding gas with elements heavier than hydrogen and helium. Carbon, oxygen, nitrogen, iron, ingredients that would one day form planets, oceans, and even living beings, were first forged in those early stellar furnaces. In this way, the raw materials for future complexity were scattered into the universe, carried outward in shock waves that seeded the next generations of stars. Galaxies in this youthful era were like seedlings, unsteady but brimming with potential. Their shapes were rough and undefined, their masses small compared to the giants that would follow. And yet, they were already laying the groundwork for the evolution of everything to come. Within them, stars clustered, gas swirled, and black holes at their centers began their quiet work, feeding on matter and shaping their hosts even from the earliest times. The universe was alive with growth, and though it unfolded in slow motion compared to the pace of human life, each step carried the cosmos closer to the rich tapestry we witness today. Collisions were more common in that crowded youth of the universe. Galaxies, still small and fragile, bumped into one another far more often than they do now. When they collided, they merged, growing larger, becoming more structured. These mergers were not destructive, so much as formative. Each one was like a stone added to a wall, building up the vast systems that now dominate the night sky. Through this slow accumulation, galaxies matured, and with them the universe itself. Some galaxies, by chance or by circumstance, grew into spirals. Their disks formed as clouds of gas flattened and rotated, giving rise to those long, graceful arms where stars continued to be born. Others became ellipticals, their shapes puffed into smooth, rounded collections of older stars, and some never quite found a symmetrical form, remaining irregular, shaped by interactions too turbulent to allow for neat patterns. But no matter their eventual identity, all galaxies shared the same origins, small beginnings, fed by gravity, enriched by stars, sculpted by time. Among the most famous examples of galactic encounters are those that we see today in mid-performance, frozen in light that has traveled millions of years to reach us. They remind us not only of what galaxies are, but what they have always been, changing, interacting, becoming. Take the antennae galaxies, for instance, two spirals caught in the act of merging. Their bright overlapping centers glow with furious starburst activity, while enormous tidal tails stretch outward like long antennae, giving them their name. These tails are not just decorative features. They are evidence of stars and gas pulled into vast arcs by the relentless pull of gravity. In them, astronomers have found clusters of new stars, blue and brilliant, shining with youthful energy. It is as if the collision itself has breathed new life into the galaxies, sparking fireworks that will blaze for hundreds of millions of years. To gaze at the antennae is to witness creation wrapped in apparent chaos. Observations across different wavelengths reveal the richness of this process. Infrared light shows dust glowing with heat from newly formed stars. Ultraviolet reveals the fierce radiance of young stellar clusters. Radio waves trace vast hydrogen clouds stretched across space. Piece by piece, the portrait becomes clear. This is not an end, but a transformation. In a few billion years, the antennae will no longer appear as two distinct spirals. They will have relaxed into a single, larger elliptical galaxy, smoother and calmer than the turbulent form we see now. But for this brief moment in cosmic time, they are both disorder and beauty, captured in a rare stage of transition. If the antennae are the rock stars of galactic collisions, all drama and spectacle, then the whirlpool galaxy might be thought of as the glamorous film star, a paragon of elegance. Sitting some 23 million light-years away, it is a face-on spiral so perfect in its symmetry that it almost looks unreal. Its arms wind outward in flawless spirals, each curve glowing with the light of billions of stars. Yet even this serene beauty hides a story of interaction. A smaller companion galaxy, tugging subtly on its structure, has distorted the whirlpool's arms, drawing out material and triggering fresh bursts of star formation. Seen through the eyes of the Hubble Space Telescope, the whirlpool is breathtaking. Dark lanes of dust curl gracefully across its arms, like brushstrokes on a canvas. Pink regions glow where massive stars are being born, and clusters of blue stars shine like jewels scattered across the galactic disk. Its companion, though much smaller and dimmer, exerts an outsized influence, reshaping the whirlpool into an even more spectacular form. The two are locked in a cosmic partnership, one dramatic and photogenic, the other quiet but powerful. And eventually, as with all such encounters, the companion will be absorbed, leaving behind a galaxy transformed once more. Then there is the Cartwheel Galaxy, a vision so unusual that when it was first discovered, it puzzled astronomers. Located about 500 million light-years away, it looks for all the world like a giant wheel rolling through space. A bright outer ring of stars surrounds a central hub, with faint spokes radiating inward. completing the illusion. The cartwheel shape is not a natural design, but the aftermath of a dramatic event. A smaller galaxy is believed to have passed directly through its disk, creating ripples that spread outward like circles on water. These ripples compressed gas as they traveled, igniting waves of star formation. The glowing outer ring is the leading edge of that ripple, ablaze with young stars. It is both a work of physics and a work of art, a reminder that the universe is capable of producing patterns so striking they seem deliberate. The antennae, the whirlpool, the cartwheel, these are the celebrities of the galactic world. They appear on posters, in textbooks, as screensavers and symbols of cosmic wonder. But they are not just beautiful images. They are laboratories, offering astronomers clues about how galaxies grow and change. Each is a chapter in a larger story, a record of how collisions shape the universe. The antennae show the furious middle act, starbursts igniting as structures stretch and bend. The whirlpool demonstrates how even subtle encounters can refine beauty into perfection. The cartwheel reveals the creativity of cosmic events, reshaping ordinary disks into extraordinary forms. Yet what unites them most is the reminder of impermanence. The antennae will merge into something calmer. The whirlpool will eventually absorb its partner. The cartwheel's bright ring will fade as its stars age. What we see now is only a snapshot, a moment in cosmic time, captured by light that has traveled millions of years to reach us. The beauty is temporary, but in that fleeting glimpse, we are given the gift of wonder. At the heart of many of these galaxies, hidden in their fenners, lies something even more mysterious: supermassive black holes. These are giants in every sense of the word, with masses millions or even billions of times greater than the Sun. Yet they occupy regions of space smaller than our solar system. Invisible by nature, they reveal themselves through their influence. Stars whip around them at tremendous speeds. Gas clouds heat as they spiral inward. And sometimes entire galaxies blaze with the radiation of matter falling into these invisible depths. The relationship between galaxies and their central black holes is profound. Observations show that the size of a black hole is linked to the size of its galaxy's central bulge of stars. It is as though galaxies and black holes grow together, feeding one another across billions of years. And when galaxies collide, their black holes eventually collide as well, setting the stage for some of the most dramatic events in the universe. Imagine two galaxies on a slow collision course, each carrying a supermassive black hole at its core. As the galaxies draw together, their stars and gas are flung into new orbits, their shapes stretched and distorted. Over millions of years, their centers drift closer. The black holes, each invisible yet immensely powerful, are drawn toward one another. At first, they orbit slowly, circling within the newly merged galaxy. Then, gradually, they spiral closer, their dance tightening, their embrace inevitable. Two titans, unseen but felt, converging in a cosmic performance that will reshape their world. As these two supermassive black holes circle each other, they disturb the very fabric of space and time itself. Ripples spread outward, known as gravitational waves, carrying energy away and drawing the pair closer with every orbit. The closer they spiral, the faster they move, until in their final moments they whip around one another at nearly the speed of light. And then, in a single instant, they merge. The collision of two invisible giants releases more energy than all the stars of the observable universe shining together, though that energy does not emerge as light, but as gravitational waves cascading outward across the cosmos. For most of human history, such events were only theory, predictions scribbled in Einstein's equations. But in 2015, those ripples were detected on Earth for the very first time. The Laser Interferometer Gravitational Wave Observatory, LIGO, recorded the faintest stretching and squeezing of space itself, caused by two black holes colliding over 1 billion light-years away. The signal lasted only a fraction of a second, but in that moment, humanity confirmed that the universe speaks not only in light, but also in waves that vibrate through existence itself. Each detection since then has been like a whisper from the deep universe, a message carried across unimaginable distances, telling of collisions that reshape galaxies and alter the course of cosmic history. When galaxies merge, their central black holes eventually merge too, though the timescales are vast. At first, the two giants orbit one another, slowed by the drag of surrounding stars and gas. Then, when they grow close enough, gravitational waves take over, shrinking the orbit further until nothing can prevent the final embrace. The merged black hole becomes the new anchor of the galaxy, its gravity binding together stars and gas, its hunger shaping the future of its environment. The process is patient, deliberate, and unstoppable, a slow-motion dance performed on a stage as wide as the universe itself. What makes this story extraordinary is not only the enormity of the forces involved, but the patience with which they unfold. Millions of years for orbits to tighten, billions of years for galaxies to drift together. Entire epochs, passing as stars are born, live out their lives and fade, while two invisible giants inch closer, step by step. To us, time is short. A lifetime is a flicker. But for the cosmos, time is vast enough to allow such slow dances to play out in full. And within that patience lies a strange kind of comfort. The universe does not rush, yet everything still finds its place. It's tempting to imagine these events as destructive, terrifying even, but the reality is often more serene. For the vast majority of stars within a galaxy, even during a collision, nothing catastrophic happens. Stars are so far apart that the odds of any two directly colliding are vanishingly small. If the Sun were the size of a marble, the nearest star, Proxima Centauri, would be another marble placed hundreds of kilometers away. Galaxies may look dense in photographs, but in truth, they are mostly emptiness. When two galaxies pass through each other, their stars continue to orbit as they always have, their nuclear furnaces burning on, largely indifferent to the chaos around them. What changes are their orbits. Some stars are tugged into long arcs, becoming part of tidal tails that sweep into the dark. Others drift inward, closer to the galactic core. Some may even be flung outward entirely, ejected into intergalactic space as lonely wanderers. But for most, life goes on much as before. Planets still circle their stars. Seasons continue to pass. If life exists on those worlds, it may never even notice that the galaxy itself is being reshaped. There are, of course, exceptions. A close encounter between stars during such an event could destabilize planets, hurling them into new orbits or even ejecting them into the void as rogue worlds without suns. But such events are rare. The overwhelming truth of galactic collisions is not violence, but transformation. The stars endure, even as their great cosmic city is restructured around them. And when we step back from the perspective of an individual star to the galactic scale, the artistry becomes undeniable. Collisions do not just shuffle stars and gas, they create breathtaking new forms. Tidal tails sweep outward in arcs that stretch hundreds of thousands of light years. Bridges of stars link galaxies like luminous threads. Streams of stellar light loop across the heavens, remnants of smaller companions consumed long ago. To look upon these features is to see physics expressed as art. Gravity sketching across the sky with a patient hand. Time itself, the brush that spreads each curve. The antennae's luminous arcs, the whirlpool's refined spirals, the cartwheel's rippling rings. All of them are examples of this cosmic artistry. And yet, what makes them so captivating is their impermanence. Tails fade back into their galaxies. Rings dissolve as stars age. Bridges collapse. Streams disperse. The beauty is fleeting, lasting only hundreds of millions of years. A blink, in cosmic terms, before the shape changes again. And still, in that blink, we happen to be here, looking up, seeing them just as they are now. It feels almost like a gift, a fleeting chance to witness the poetry of physics at its most extravagant. What ties all of this together is the realization that galaxies are not static monuments. They are alive with motion, with growth, with encounters that change their shape and destiny. They are chronicles of time, each star a sentence, each collision a chapter. They remind us that the universe is never finished, never fixed. It is always becoming something new. At their core, galaxies carry both chaos and order. Chaos in their collisions, their turbulent gas clouds, their unpredictable encounters. Order in the structures that emerge, spirals, rings, ellipses, patterns that echo across billions of light years. In this duality lies the true wonder of the cosmos. A universe where physics can carve beauty, where even the most immense forces create not only destruction, but renewal. And for us, tiny observers on a small planet circling an ordinary star, this grand story offers perspective. Our lifetimes are short, our concerns immediate. Yet above us, galaxies move at a pace so patient that their transformations seem eternal. They remind us that time itself is vast enough to hold all things, our fleeting lives, our civilizations, and the endless arcs of stars drifting across the sky. To watch galaxies is to watch time itself stretched thin, woven into light and shadow across the heavens. To study them is to read a story that began long before Earth was formed and will continue long after it is gone. They are not just ornaments scattered across the night. They are the universe's way of writing poetry. Poetry composed not in words, but in starlight. From the vantage point of a star, even the most dramatic galactic events unfold with a patience that seems endless. Stars live for millions, sometimes billions of years, their steady light, undisturbed by the upheavals of the galaxies they inhabit. The Sun, for example, is roughly halfway through its 10 billion year lifespan. And in that span of time, galaxies may drift together, collide, and merge into new forms altogether. Yet the Sun will continue shining, uninterrupted, a timeless beacon in the vast cosmic ocean. Seemingly unaffected, its glow steady, its rhythm unbroken. From the perspective of a star, the galaxy is not a fixed or stable home, but a shifting backdrop, like scenery being changed behind the stage of a theater while the performance itself carries on uninterrupted. When galaxies do collide, they create opportunities for entirely new stars to come into being. Vast clouds of gas, invisible to the human eye, but abundant throughout galaxies, are jolted by the gravitational turmoil of a merger. These clouds crash together and compress, and within those dense pockets, new stars ignite. For these newborn suns, the collision is not a disruption, but a reason for their existence. Without the violent embrace of galaxies, without that forced compression, the gas might have drifted indefinitely, never condensing into the brilliant fires of fusion. Collisions, in that sense, are midwives, ushering new life into the cosmos, ushering entire generations of stars into being. And those stars often blaze fiercely, burning blue-white and living short, dramatic lives, measured in only a few million years before ending as supernova. Their existence is fleeting, but transformative, seeding their surroundings with heavy elements that will enrich the next cycle of star and planet formation. Meanwhile, older stars remain serene, seemingly indifferent to the cosmic choreography around them. Whether the star drifts slightly outward into a new orbit, is gently tugged toward the galactic center, or remains in the neighborhood where it began, its fundamental existence hardly changes. At its core, fusion continues, hydrogen being pressed into helium, releasing energy in a process that has endured since its birth. The star is steady, a lighthouse shining through the storms of galactic transformation. Even when supermassive black holes at the centers of galaxies merge, unleashing gravitational waves and reshaping the core of the system, stars located far from those centers carry on, their light unbroken, their cycles uninterrupted. It is this paradox that makes galactic collisions so fascinating. To human eyes, they appear as some of the most spectacular events in the cosmos. Grand arcs of stars, luminous bridges of gas, cataclysmic rearrangements on unimaginable scales. And yet, for the majority of the stars involved, life continues as if little has changed. They are quiet affairs, little more than background music, playing while they continue their ancient routines. The contradiction is humbling. What we see as cosmic fireworks, most of the participants experience as gentle shifts, too slow and subtle to notice. This endurance is perhaps the most poetic lesson that galactic collisions have to offer. Change can be immense, yet for those who live within it, life can remain steady. Human lives are measured in days, years, and decades, fragile, fleeting, and deeply bound to short cycles of time. Stars, in contrast, measure their lives in spans so long that change becomes almost imperceptible. They persist through upheaval, their flames steady, while galaxies twist, stretch, and reshape themselves around them. To imagine the perspective of a star is to step into a scale of patience that defies comprehension. Change is constant, but it arrives with such slowness that even dramatic transformations unfold like whispers. There is a certain comfort in imagining our own sun carried along in the future merger between the Milky Way and Andromeda. Long after humanity is gone, long after Earth has become unrecognizable or uninhabitable, the sun will continue its steady burning, while spiral arms warp and tidal tails sweep outward. While the two galaxies' cores spiral closer and closer together, the sun will shine on, a steady beacon in its small corner of space. Perhaps Earth will still circle it, perhaps not, but the act of shining will remain, indifferent to the larger transformations surrounding it. In this endurance lies a profound reminder. Beauty in the universe does not always emerge from chaos or upheaval. Sometimes it comes from constancy, from resilience, from the ability to endure quietly while everything else changes. Galaxies may collide and merge, their forms altered forever. But the stars remain, shining steadily as the universe around them reshapes itself. Their constancy is its own kind of poetry. Less dramatic than tidal tales or colliding black holes, but no less beautiful. And yet, even as stars persist in their quiet glow, the galaxies themselves undergo transformations of breathtaking scale. The first signs of a collision are often found in their altered shapes, spiral arms stretched into ribbons, luminous bridges arcing between two once separate disks, streams of stars flung outward into space like brushstrokes across the night. These great arcs and tendrils are evidence not only of the galaxy's disruption, but of the immense creativity of gravity. The real drama, though, often happens in the invisible substance between the stars. The clouds of gas and dust that fill galaxies like unseen oceans. Though they may sound unremarkable, dust and gas, words that conjure images of mundane particles, they are in fact the fertile soil of the cosmos. Interstellar gas, made mostly of hydrogen, floats as a thin mist, while dust grains, tiny fragments of carbon, silicon, and heavier elements, scatter light and shape the appearance of nebulae. These raw materials are the foundation of all that follows: stars, planets, and life itself. Without them, galaxies would be barren collections of aging suns. With them, they become nurseries alive with possibility. When galaxies collide, these reservoirs of potential are stirred and shaken, compressed into action. Gas clouds that once drifted lazily are forced together, their densities rising until gravity overwhelms internal pressure. Within the collapsing knots, protostars form, dense seeds that ignite nuclear fusion and shine with new light. To the eye, this looks like sudden creation, light blooming where once there was only darkness. Astronomers call these periods starbursts, for they unleash star formation at rates tens or even hundreds of times higher than a galaxy's usual pace. During a starburst, regions that once glowed faintly erupt with clusters of blue-white stars, burning fiercely but briefly. The galaxy itself becomes more luminous, filled with radiant patches of newborn suns. Some of these stars will be steady like our sun, long-lived and stable. Others will be massive giants that blaze for only a few million years before exploding in supernovae, scattering their enriched remains into space. In this way, collisions not only create beauty, but also accelerate the universe's chemistry, spreading the carbon, oxygen, and iron that future generations of stars, planets, and perhaps life will depend on. Nebulae play a central role in this transformation. These colorful clouds, so often the subjects of iconic astronomy images, become the theaters where starbursts unfold. In colliding galaxies, nebulae are stretched, compressed, and shocked into glowing action. Their filaments collapse into knots, their gases heated and ionized by newborn stars, radiating in hues of red, green, and blue, depending on their composition. Red from glowing hydrogen, green from oxygen, blue from helium, together creating vistas as vibrant as earthly gardens in bloom. The resemblance is fitting, for these clouds are truly gardens of creation. Galaxies act as cosmic gardeners, stirring their soil, planting new clusters, and replenishing the universe with fresh light. The metaphor of gardening captures the essence of collisions. Old stars live out their lives,
ending in supernovae that scatter the elements of life into the interstellar medium. Collisions recycle those remains, stirring them back into new shapes, triggering fresh rounds of starbirth. It is destruction and creation intertwined, one process feeding the other in cycles that span billions of years. Even from Earth, millions of light years away, we can glimpse these cosmic gardens at work. Telescopes reveal arcs of star formation, glowing knots scattered like jewels across distorted galactic arms. Each one is proof that collisions, though they may seem catastrophic, are engines of renewal. The scale of this creation is staggering. A single collision-induced starburst region can contain thousands of new suns, each one a potential harbor for future planets, each one carrying the possibility, however remote, of life. Some will burn quietly for billions of years. Others will blaze briefly and end in spectacular death. Together, they enrich the galaxy with diversity, ensuring that the next generation will carry forward the seeds of creation.
The physics behind this is both intricate and elegant. As galaxies interact, their mutual gravity funnels gas toward their centers. This inflow not only feeds central black holes, awakening them into quasars that shine across the universe, but also fuels starbursts in the dense cores. Meanwhile, gas clouds in the outskirts collide directly, sparking starbirth in unexpected places, creating glowing knots and patches far from the galactic center. The result is a galaxy peppered with light, a patchwork quilt stitched by the hand of gravity itself. But these bursts of creation cannot last forever. Intense star formation consumes gas rapidly, and in only a few 100 million years, the reservoir runs low. The blaze of youth fades, leaving behind a calmer, redder galaxy filled with older stars. The transformation is profound. What was once chaotic and luminous settles into maturity, trading brilliance for stability. Collisions, then, are accelerators. They push galaxies through their evolutionary stages, forcing change more quickly than time alone would dictate. Astronomers know that to witness a galaxy in the throes of a starburst is to glimpse a rare and precious moment. Collisions and their ensuing fireworks are fleeting in cosmic terms. Galaxies spend far more time in quiet phases than in these brief acts of brilliance. To see one caught mid-burst is to catch the universe mid-sentence. To witness vitality flaring across a canvas of deep time. It is a reminder that even in the ancient vastness of the cosmos, there are still moments of sudden renewal, sudden youth, sudden beauty. And so, as galaxies collide, they reveal themselves not as engines of destruction, but as gardeners, cultivators, caretakers of light. They recycle, they renew, they sow new stars into the fields of darkness. They are the universe's way of ensuring that it never grows barren, but always remains alive with possibility. The brilliance of collisions eventually gives way to calm. The fireworks of starbursts fade, the gas is consumed or expelled, and the galaxy settles into a quieter, steadier existence. What begins as a turbulent dance of tidal tails and luminous clusters slowly resolves into a unified whole, its scars smoothing with time. The chaos does not vanish immediately. Streams of stars may remain stretched across space, long arcs of light tracing the past encounter. Bridges collapse back into their cores, and faint shells or ripples may linger for billions of years as echoes of what once occurred. Yet gravity, ever patient, always pulls the pieces back into balance. Over hundreds of millions of years, the identity of the original galaxies blurs. The delicate disks that once spun with spiral arms are often destroyed by the randomization of stellar orbits. Instead of neat wheels with swirling pinwheels of light, the result is typically more rounded, an elliptical galaxy. Ellipticals are the elder statesmen of the galactic world. Smoother, calmer, their stars arranged in every direction rather than along thin planes. Their light is softer, redder, the glow of older populations rather than the blue-white sparkle of youth. This transformation represents not just survival, but a kind of maturity. A spiral is dynamic, full of gas and dust, producing stars with vigor. An elliptical is settled, having spent much of its fuel, glowing more with memory than with youth. Yet within that quiet is a deep beauty of its own, a galaxy no longer aflame with sudden bursts, but steady, dignified. Its light, the accumulated glow of countless suns aging together. From afar, elliptical galaxies appear as golden ellipses suspended in the dark. Their forms are smooth, their brilliance warm, like cosmic sunsets stretched across the heavens. They may lack the intricate arms and luminous bursts of spirals, but they radiate serenity. And in the densest regions of the universe, clusters where galaxies gather by the hundreds or thousands, ellipticals often dominate. At the centers of these clusters, the largest ellipticals swell to unimaginable sizes, some containing trillions of stars. They are patchworks of past mergers, colossal archives written in starlight. Each one is the product of countless unions, each star a word in a long, patient chronicle of creation and change. Even in this quieter phase, galaxies are not lifeless. Stars continue to orbit. Globular clusters still swing through their halos, and supermassive black holes remain at their cores. Occasionally, a stray galaxy drifts too close and is absorbed, feeding the giant further. But compared to the tumult of collisions, life in an elliptical is far more measured. The music slows, the rhythm softens, and the galaxy enters a twilight that can last for trillions of years. It is here, in this quiet aftermath, that one of the universe's gentlest lessons emerges. Storms end. Turbulence, no matter how grand, is temporary. The blazing youth of starbursts fades, replaced by the calm glow of age. To look at an elliptical galaxy is to see not only survival, but contentment, the serenity of a system that has endured upheaval and emerged into stability. The path to this serenity is shaped by physics. During a collision, the orderly orbits of stars are scrambled. Spirals depend on thin rotating disks to maintain their graceful arms. But when two galaxies interpenetrate, their stars are jostled into random orbits. The coherent pattern dissolves, leaving behind a rounded form. What seems visually simple is in fact the sum of billions of gravitational interactions reaching equilibrium. The result is a galaxy with no preferred direction, a smooth glow rather than a structured whirl. Gas plays a role as well. Collisions fuel furious bursts of star formation, but this consumes gas rapidly, and powerful winds from supernovae and active black holes push the remaining gas outward into intergalactic space. With little fuel left, star formation slows, and the galaxy ages. The young blue glow fades, replaced by the steadier, warmer light of older suns. It is a transition from chaos to stability, from youth to maturity. Some of the most massive galaxies we know today are products of this cycle, repeated countless times. Their sheer size is proof of the universe's restlessness, and yet their calm light is proof of its balance, the inevitability that even in chaos, order eventually emerges. From the human perspective,
These transformations are metaphors writ large across the sky. Life, too, contains upheaval, moments of turbulence, bursts of change, times when everything seems uncertain. But just as galaxies eventually settle into equilibrium, so too does the universe remind us that calm follows chaos. The elliptical galaxies, glowing softly in the night, are like lanterns of endurance, testimonies that storms can be survived and peace rediscovered. Perhaps the most striking example of this truth is written in our own future. If you step outside on a clear night and gaze toward the constellation Andromeda, you will see, faintly, a blur of light. To the naked eye, it appears as little more than a smudge, easily overlooked. Yet that smudge is an entire galaxy, the Andromeda Galaxy, our nearest large neighbor. Like the Milky Way, it is a spiral brimming with hundreds of billions of stars, and it is on a direct path toward us. This is no brief visit. In roughly 4 billion years, Andromeda and the Milky Way will meet in a cosmic embrace. They will not graze and separate, but merge fully, their shapes distorted, their stars flung into arcs and bridges, their gas compressed into furious bursts of star formation. To imagine such an event is to stretch the mind beyond measure. Two entire galaxies, each vast beyond comprehension, colliding and weaving into one. Yet for the stars themselves, the story will be quiet. The sun will continue to shine, carried along on whatever new orbit gravity writes for it. Planets will still circle their stars, seasons will still pass. From the perspective of life, if any still exists on those worlds, the merger may go entirely unnoticed. To those beings, the night sky might slowly shift over millions of years, constellations unraveling and reforming. But daily life would carry on, unaffected by the grand stage beyond.
Still, the sight from afar will be breathtaking. The sky will fill with arcs of light, new stars blazing in clusters, streams of brilliance stretching from horizon to horizon. If Earth survives long enough for humans or their descendants to witness it, the heavens will look utterly transformed. For billions of years afterward, the two galaxies will weave together until finally they relax into a single structure, likely an enormous elliptical. The Milky Way, once a graceful spiral, will become part of something vaster and calmer. A new system glowing steadily in the darkness. By then, the sun itself will be nearing the end of its life, its fuel dwindling, its light shifting. Earth may no longer be habitable because our lifespans are brief flickers compared to the slow merging of galaxies. Comforted because the universe shows us that even upheaval leads to new forms of beauty, and that continuity is woven into its fabric. They are creation through contact, renewal through union, poetry written not in words, but in starlight. We can take solace in knowing that we are part of this grand cycle, a cycle that began long before us and will continue long after. The quiet glow of elliptical galaxies tells us that calm always follows chaos, yet the universe never rests for long. Even our own Milky Way carries a future written in gravity's script, a destiny slowly approaching from across the void. If you gaze toward the faint blur of the Andromeda Galaxy, you are looking at the partner in our galaxy's next great dance. At this very moment, Andromeda is moving toward us at about 110 kilometers per second. It sounds astonishingly fast, yet across the 2.5 million light-years that separate us, it is more of a steady drift than a headlong charge. Imagine two great ocean liners sliding across a vast sea, gliding so slowly that their eventual meeting seems postponed forever. And yet, the outcome is certain. In roughly 4 billion years, the first act of this cosmic ballet will begin. Long before then, Andromeda will grow brighter and larger in our night sky, no longer a faint smudge but a luminous disk dominating the heavens. When the galaxies finally touch, their stars will not crash into one another as one might expect. The distances between them are so immense that even in collision, the odds of two suns colliding are almost zero. Instead, what unfolds will be a grand reshaping. Tidal streams of stars arcing across the heavens, spiral arms stretched and twisted into ribbons, and bursts of new stars igniting where gas clouds are compressed. The merger will not be a sudden crash, but a prolonged embrace. The first pass will fling out great tidal tails, like dancers' arms sweeping wide in mid-motion. Then, drawn back together, the galaxies will meet again and again, their structures unraveling a little more with each encounter. Over billions of years, the dance will settle into a single new galaxy, rounder and smoother than either parent. An enormous elliptical, sometimes nicknamed Milkdromeda. And what of our own solar system? The fate of the sun and its planets will be shaped by the shuffle of orbits. Some stars will be cast outward into tidal streams, others pulled inward toward the new center. Our solar system could find itself drifting far from the heart of the galaxy, or plunged closer than ever before. For any future descendants of humanity, the night sky would be utterly transformed. Familiar constellations would dissolve, replaced by alien patterns, while vast glowing arcs of starlight stretched across the heavens. The view would be spectacular, though the drama would unfold so slowly that no single generation could ever see it change. The idea of this looming encounter can feel almost humorous in its scale. While we worry over the tasks of days and decades, the universe has already scheduled a meeting of galaxies, a collision of hundreds of billions of stars, to unfold in a timeline measured in billions of years. The deadline is so gentle, so patient, that it invites not fear but awe. To understand this future more clearly, astronomers have turned to one of humanity's greatest tools, simulation. Feeding the known masses, motions, and dark matter halos of both galaxies into powerful computers, they let the laws of Newton and Einstein play out on the screen. The result is not an artist's guess, but the choreography of gravity itself, sped up so we may glimpse billions of years in moments. What these simulations reveal is not a crash, but a courtship. Andromeda does not slam into the Milky Way and stop. Instead, the two galaxies weave through one another, recoiling and returning like dancers in orbit. Each pass strips stars into tidal streams, stretches spiral arms into luminous arcs, and sends ripples of star formation flashing across their disks. Only after many such encounters do the galaxies finally settle into a new form, a massive, rounded elliptical, glowing with the light of 1 trillion stars. Perhaps the most surprising revelation is how peaceful this drama is for the stars themselves. Space is spacious, and though the galaxies merge, their suns almost never collide. Most are simply nudged into new orbits, drifting outward or inward, depending on the tides of gravity. To a star, the merger is not destruction, but rearrangement, a gentle rewriting of its place in the galaxy's story. For our solar system, the odds favor survival. Earth, Mars, and whatever worlds humanity may one day inhabit
are likely to remain bound to the sun, carried intact through the reshaping of the galaxy. Whether Earth itself remains habitable is another matter. Billions of years from now, the sun will grow hotter, brightening until oceans may boil away. But regardless of our fate, the sky above will one day bear witness to a spectacle unlike any humanity has ever known. Two galaxies becoming one, unfolding across the endless night. The simulations of our galaxy's future are not just windows into what is to come. They are also reminders of what has already been. Every galaxy in the sky, from the graceful spirals to the featureless ellipticals, carries the scars of past encounters. To understand what lies ahead for the Milky Way, it helps to look back to the universe's youth, a time when collisions were not rare dramas, but the daily rhythm of creation. In the early universe, not long after the Big Bang, matter had not yet spread far. The cosmos was smaller, denser, and crowded with young galaxies still finding their shape. They were not the vast sweeping structures we recognize today, but smaller, clumpier systems bursting with gas and stars. Packed close together, they were bound to collide. The night sky of that era would have been a scene of near constant mingling, galaxies brushing past one another, merging and reshaping at a pace that seems frenetic compared to the long stretches of calm we see today. Telescopes like Hubble and the James Webb Space Telescope allow us to peer across billions of light years, back toward those ancient times. Many of the galaxies we see in those distant views appear warped, chaotic, or irregular. To the untrained eye, they might look broken, as though something went wrong. But in truth, they are snapshots of growth in progress. Galaxies caught in the act of colliding and merging. What looks like cosmic disorder is really the blueprint of construction, the universe assembling its grand architecture. These early collisions were fiery affairs, with galaxies rich in gas. Every encounter was like striking flint against steel. Clouds of hydrogen slammed together, compressing into knots that collapsed under their own gravity. Waves of star formation ignited in furious bursts known as starbursts. For a few million years, a blink in cosmic time, these newborn stars shone fiercely blue, living fast and dying young in titanic explosions of supernova. The violence seeded space with heavier elements, scattering the raw materials that would one day form planets, oceans, and living creatures. This cycle, collide, ignite, enrich, repeat, was the universe's way of maturing. Just as cities grow from the union of smaller towns, galaxies grew from the fusion of smaller fragments. Astronomers call this process galactic assembly. Over billions of years, small irregular galaxies merged into larger and more organized forms. The spirals and ellipticals we see today are the refined descendants of that crowded, turbulent past. Our own Milky Way is no exception. Hidden within its halo of stars are remnants of long-vanished galaxies, their stars stretched into streams that wrap around our spiral like faint signatures. By studying the chemical fingerprints of those stars, the exact mix of elements forged in their birthplaces, astronomers can trace them back to smaller galaxies that once existed on their own before being swallowed by the Milky Way. In this way, our galaxy is not a single, pristine creation, but a tapestry woven from many ancestors. Collisions also nurtured the growth of the universe's most enigmatic giants, supermassive black holes. These behemoths did not appear fully formed. They began as seeds, perhaps the remains of massive stars or dense clusters of matter. But when galaxies collided, torrents of gas were funneled toward their centers. feeding the black holes in frenzies that lit up the cosmos as quasars, brilliant beacons visible across billions of light years. Over time, repeated collisions and repeated feedings allowed black holes to swell to millions or even billions of solar masses, anchoring their galaxies in place like invisible keystones. Sometimes, mergers brought not just gas, but other black holes. When two galaxies with central black holes merged, their cores were dragged into a slow, spiraling dance. For millions of years, the black holes orbited one another, their embrace tightening as gravitational waves carried energy away. Eventually, they coalesced in titanic mergers, sending ripples across the fabric of space-time itself. These events, still happening across the universe today, are faintly detectable with our most precise instruments, each signal a whisper from the ancient dance of galaxies.
The role of collisions in shaping the cosmos cannot be overstated. Without them, galaxies would likely have remained small and irregular, their gas unshaken, their stars scattered. Instead, mergers allowed galaxies to grow massive. Starbursts enriched the universe with heavy elements, and black holes found the fuel to become giants. Every star in the sky, every atom of carbon in our bodies, every glimmer of light we see through a telescope has been touched in some way by the great ballet of galactic collisions. And so, as we look toward the Andromeda Galaxy and imagine its slow approach, we are not only glimpsing the future, we are seeing a continuation of a process as old as time itself. The Milky Way's fate is written into the same story that shaped every galaxy before it, a story of encounters, mergers, and renewal. From the chaos of collisions comes order, from destruction comes creation, and from the endless pull of gravity comes the quiet assurance that the universe is always in motion, always evolving, always dancing. From the lazy scientist, sleep well and good night.